Thank you. All right.
You're the one that gave yourself the name _
Yes, my name is ... All right.
This is a particle podcast. WA Science told different. Powered by Scitech.
Good evening, everybody. My name is Leon.
And I'm Beth.
And welcome to Please Look Up, your monthly deep dive into space news.
And commentary.
Recorded at Scitech on Wajak Noongar land. And welcome to the January edition, the first one of 2025.
We're back. It's 2025. What's up this month, Leon?
Well, the sky stops for nobody. And this month, it's an awesome month. It's a parade of planets.
A parade of planets.
That's the best way of putting it.
That's a lovely phrase.
You go outside and you will see planets during this month. So let's get cracking into those planets because you can actually see every single planet this month if you're really on the ball.
So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune?
Yes,
all of them?
All of them.
Every single one?
Every single one, although to be honest, Mercury's a bit shit.
Oh.
So. But everything else, pretty good going.
Okay, all right.
So we'll start in the evening sky, as we always do, and the same planet that we've been mentioning for about the last 6 months now, in the western sky after sunset.
It's Venus!
It's Venus. There's not much we can say about Venus that we haven't already said, except for the fact that it is approaching the end of its sort of domination of the night sky over the next couple of months. So you still have a long time to look at it, but by about mid-March it's going to be gone. So, you want to try and get one last look in the next, 4 or 5 weeks before it's gone.
Okay. Will it be back?
It'll be back. It'll be gone from the skies for about a month, and then it will appear in the eastern sky in the morning. Ooh. And there it will stay for another 6 or 7 months. So, if you tune into the July podcast, or hello, if you've just tuned in from the July podcast and are re-listening to the January.
We're not going to be useful. Skip forwards to the bit where we talk about what's not happening tonight.
Yes, you'll hear us talking about it in the morning sky after that.
Fun. So Venus is still here.
Yes.
Saturn
is not too far from Venus. Mm-hmm. These are both in the western sky after sunset, northwestern.
Okay. So as always, we've watched the sun go down, and they're there.
Yes, yeah, they're just there.
Maybe even slightly before the sun has fully gone down sometimes.
You can definitely see Venus. Saturn, I think you probably have to wait until the sun's almost gone. But yeah, they're both there. Saturn's just a little bit off to the side. It's kind of faint and yellowish. It's not the best time of year to look at it, to be honest. But if you know that it's there, or if you use stellarium to find it, then you'll have no trouble spotting it.
Awesome. So we're going back across the sky, sort of. So we've got Venus and Saturn.
Yeah, just kind of facing the west. Then we're going to pivot and turn to our right.
Oh, we don't normally turn right.
No,
we turn left.
Yeah, we normally turn left.
Oh, we're going to turn right. Okay, looking north.
Yeah, hang on. Which way is Zoolander? Zoolander can?
He can only turn left.
He can only turn left. Yeah. We're at the climax of the Zoolander movie where he turns right.
Yeah.
And we're going to turn right and face to the north.
Really up-to-date reference there, Leon.
Yes, thank you. That's about the last movie I saw.
I watched it last year.
Yeah.
And I was like, oh my goodness. I remember this film, it's great. Sorry.
Yeah.
Anyway, so we've turned right,
north,
unlike Zoolander.
Yeah. And facing north, you'll see the biggest, brightest of them all, actually not the brightest, but the biggest, Jupiter.
Now, Jupiter, I have a trick for spotting at this time of year because it is chilling out near our friend Orion.
Yes.
And Taurus. So if you can find, Taurus's horns, Jupiter's basically in them, between them.
It is, that's right.
So it's pretty easy to find. But it does make spotting Sirius, the brightest star in the night sky, a little bit off-putting because Jupiter is so, in the general scheme of things, so close and so bright that it always makes me do a little bit of a double take because I'm looking north. There's a really bright thing over there. Is that Sirius?
Ah, I see.
No, it's Jupiter.
No.
Sirius is on the other side of Orion.
Sirius is on the other side of Orion, that's right. We did actually describe how to find Sirius in a previous edition, that's right. Now, to clarify as well, we're talking at about 9 p.m. at night this month. So 9 p.m. any night of January, this is what you'll see. So then you keep going, and we keep turning right until we're sort of facing towards the northeast. Mm-hmm. And there is one more very easily spottable planet, which is the red planet. Mars.
So what about all the other ones?
Well, they are much harder to see, but in between, if we're looking at Jupiter again, in between Jupiter in the north and Saturn in the west, there is actually Uranus and Neptune as well. Ah. So they are there, you just can't see them without a telescope.
Right, and that's just because, even when we're talking about planets and being able to see them, they don't make their own light, they're just reflecting it from the sun, which means that when you get too far away, Uranus and Neptune, there's less light.
Yes, that's right. So the light that we see from them has to travel from the sun up to 4.5 billion kilometres to get to them, depending on which one you're talking about, and then it has to travel almost that far back to get to us.
But because, correct me if I'm wrong, but because like Jupiter is so bright even though it's further away than Mars, just because of its size, like it's so big that it can reflect that much more light. And then Venus, although it's the same size as Mars, is so much brighter because it's closer to the sun.
Yeah, a bit of that, yes. Venus is actually about twice the size of Mars, but it's also their compositions.
What is going on with my brain today?
Don't know. But the other thing, so yes, you are right, 100% that the size of the object in the first place will reflect more light and therefore be brighter in the sky. But there is also the fact that Jupiter and Venus, those specific examples you gave, are both covered in highly reflective clouds. And so those clouds themselves compound the brightness, whereas Mars is covered in sort of grey, red dirt. So it's
not very shiny.
It's not as reflective for an object of, a similar sized object if it was covered in clouds, for example.
What's the same size as Mars? Where have I gotten that from?
Yeah,
what have I read today?
What have you read?
It's got me thinking something is the same size as Mars.
Like Ganymede, the largest moon of Jupiter, is slightly smaller than Mars.
Maybe that. Maybe that.
Yeah,
maybe that's a new segment for us. What's the same size as Mars? What's the size of Mars?
Perfect. So those are the planets you'll see in the nighttime sky.
Yeah.
And those are all of all of the largest ones, which then leads us to the smallest planet in the solar system, Mercury. And to see that, it's not really trying this month, but you can see it if you go out for about an hour before sunrise. So nice and early in the morning. Sunrise is about 5 o'clock at the moment. So you need to go out before 5 o'clock in the morning, look to the east for about an hour before sunrise, and you'll be able to see Mercury.
Okay.
For about the first half of the month. After that, after about January 18th or something, it gets lost in the glare of the sun.
Right.
So it's not. You can see it. We're not misleading you, but it's not very good.
Can we ever see it well, or is it just too close to the sun for us to be able to see it well?
The latter, yeah.
Okay.
You can see Mercury, at some what's called maximum elongations, you get more than an hour. Sometimes you get a couple of hours to look at it, but to study it in great detail, especially with a telescope from Earth, is actually very, very difficult.
Yeah.
Because of that, it's so close to the sun, and it's also so close to the horizon. So you're looking through a lot more of the atmosphere, so you have a lot more turbulence. So it's just very hard to study.
And remember, kids, don't look directly into the sun.
No, it's not.
Generally good advice.
Yeah, it's generally good advice.
Yeah.
I agree.
So, looking at Mercury when it's very close to the sun, that's a dangerous game.
Now, speaking of Mars, which we mentioned before.
Looping back around.
So Mars reaches a nice milestone during January, which
is it its birthday?
Yeah, why not? It reaches what we call opposition. So last month in December, we had Jupiter at opposition.
Oh, this is when I get to stick my arms out to the sides and go...
yes.
Planet on one side, sun on the other.
Yes, that's right.
Yeah.
So on the 16th of January, as the sun sets, if you point your left hand at the sun and point your right hand exactly opposite as the sun sets, then you'll be pointing at Mars as Mars rises. And that's what we mean by opposition. And what that means is we're seeing the planet face on, which means this is the best time of year to see Mars. This is as bright as it will be. It's as big as it will be in the sky. So make sure you get the chance to look at. Make sure you take the chance to look at it while it's there, because unlike some of the other planets and the way they move around and things like that, Mars is really actually not going to be in this position for very long.
Okay.
So you've really got.
Do you mean not very long, as in like we've got a couple days or a couple hours?
A few weeks.
Oh, okay.
In, again, you'll be able to see it for the next few months, but
yes,
in terms of being how good it is right now, it's the best it's going to be for the next sort of 18 months, and the sort of best period, in brackets, quotes, is, it's only a few weeks. So make sure you take the chance while you have it.
Amazing. So we've got our parade of planets in the evening. You should be able to see all of them in the evening, except for Mercury, which is just making everyone's life difficult by being in the morning and being not very good.
Typical Mercury.
And then Mars in opposition.
Mm-hmm.
Anything else exciting going on in the night sky?
Well, not so much, I would say, the night sky, but there was just another exciting milestone that happened a few days ago as of this recording, which is...
New Year's.
Yes, New Year's did happen. But actually, when you talk about... sort of a planet's birthday. One way you could think about it is, of course, New Year's, but that's just arbitrarily defined. However, on January 4th, something actually very special does happen, which is that's when Earth reaches what we call perihelion, its closest distance to the sun.
Oh.
So
why is that not New Year's?
Yeah, I don't know.
That would make way more sense.
Yeah. There's probably a good reason, actually. But the history of the calendar is, there's quicker ways of torturing yourself than trying to read the history of the calendar.
No, and especially not taking into account the fact that the entire planet doesn't actually go by the same calendar. So I think in Ethiopia it might be 2017 now.
Oh, yeah,
There's
why not?
some weird,
I don't know. But, to clarify that, Earth's orbit is not perfectly circular. We're not always the same distance from the sun. And so during different times of year, we're closer or further away. And it just happens to be that on the 4th of January, there's a specific instant in time where Earth, as it orbits the sun, passes through that closest point.
So is it the 4th of January every year?
Good question.
No,
it's not.
It shifts a little bit.
It wobbles back and forth by a day or two.
Okay.
Up to a day, depending on the year. And then over centuries, that also drifts. But it's not going to be like on the 12th of January next year. It'll be, on the 4th or the 3rd or maybe the 5th.
Okay. Awesome. So the night sky is all about planets. So one of the things that we were going to try and do is a series within a series.
Series within a series.
A series within a series.
What have you got for us, Beth?
Well, we have some planetary mythology.
Ooh.
Yeah.
I like planetary mythologies. I've read quite a lot about them, but I know that it's quite a niche subject, and you know even more than I do.
Yeah, well, so the plan is because there's so many planets up and about tonight, great time to start a little mini-series talking a little bit about planets. So it would make logical sense if we started with the one closest to the sun, Mercury, but it looks terrible at the moment, so we're going to start with Venus.
Makes sense.
Yep.
And it's not going to be there for much longer, so let's do it before it's gone.
So, the first thing to consider when you talk about planetary mythologies is it gets a little bit PG-13.
That's an understatement.
Yeah. PG-13 minimum. If not a 15, I don't know what the rating system is in Australia.
PG-15.
Okay.
Yeah.
Yeah.
And M15 and so on.
Okay. Well, anyway, it's Greek and Roman gods. So all of the planets are named after Greek and Roman gods, or Titans, in some way, shape or form, except for Earth.
Yes.
The word Earth is a Germanic origin. It's not even Greek or Roman or Latin, which is surprising when it comes to space things. Except for Earth, everything is Greek and Roman, and as soon as you get into Greek and Roman mythology, it all goes a little bit weird. So Venus is named after the Roman equivalent of Aphrodite.
The goddess of love.
The goddess of love and beauty and victory as well in Rome. Now, it's the only lady planet, except for maybe Earth. But again, because Earth is not named after a specific figure.
No, it's like sometimes interpreted as Mother Earth, but it's not, as you say, it's not a deity of a female identity.
Exactly. And then if you get into the fact that Terra comes from Terrace, which might actually be named... anyway.
Doesn't matter.
Yeah. So Venus is the only lady planet and named the goddess of love and beauty. But I find it quite funny because it's a lady planet that is completely inhospitable and it rains acid.
Yes.
And it's got a suffocating atmosphere. It's going to crush you.
It's not a nice place, is it?
No, not a nice place at all. So a little bit about the story of Venus, if we're talking star stories.
Sure.
The Romans, basically, in a lot of their culture, assimilated the Greek culture into it.
Yes,
so a lot
they
of
did.
Venus's stories are just Aphrodite stories.
Yes.
So the Greek origin of Aphrodite was that she emerged fully formed as an adult from sea foam, which is beautiful, as depicted in Botticelli's The Birth of Venus. She's in a shell.
Yes, that is quite a famous painting.
Yeah.
It's a really good painting if you haven't
beautiful.
seen it. The Birth of Venus.
Yeah, definitely go and have a look.
Fully formed, emerging from the sea foam. Excellent.
Yeah. Do you know where that sea foam came from, Leon?
I do, but I'd love for you to tell me.
That sea foam was produced by the severed genitals of Uranus. Yes, the planet Uranus, who is actually named after the Greek titan of the sky, had his genitalia cut off by Saturn. Hey, it's all the planets. They're all up in here.
They're one big happy family.
Very unhappy family because Saturn is actually genuinely related to Uranus. Saturn is Uranus's son, and
we'll cover that in a future episode.
We will cover that in a future episode. But some good came of it all. Aphrodite. So in the Roman thought of Venus, she's actually the ancestor of all Romans.
Oh, okay. That I did not know.
So her son, Aeneas, was a Trojan hero, and he survived the fall of Troy. And this is where stuff gets really interesting when it comes to like ancient history mythology, because it all sort of merges together about like what's fact and what's story.
Yeah, and who does what.
Yeah. Well, it's also like the Icelandic sagas are really interesting in that case as well, because you have like genuine history, and then it sort of merges into this weird like, who fought a dragon? And you're like, okay. But yes, so Aeneas was a Trojan hero who survived the fall of Troy and left to Italy, and this was like a well-known enough story that Julius Caesar actually claimed to be a descendant of Venus.
Wow, there you go.
Yeah.
So all life stems from Venus.
All Roman life stems from Venus. But
and I wonder if that is then harking back to, the observable biological fact of like women and childbirth and life producing.
Yeah, and I don't know if that's sort of where that's come from, of like, because she's the goddess of love as well, and not just like love, like Valentine's Day love, like she's closely connected to like erotic love as well. Like that is, I mean, the consequence is often more humans. So yeah, it's interesting, but then of course it all goes wrong when you combine it with any other mythologies like Romulus and Remus, who are the fathers of Rome.
Yeah, that's right.
So yeah, basically for everything there's like 3 or 4 different origin stories that have been like mistold or differently translated, or things have been given several names, like don't get me started on the moon and how the moon goddess is Artemis and Selene, and neither of them and both of them. So yeah, there's all sorts of stuff like that. But what I found quite interesting was that when we link back our mythologies, you would think that Venus, the planet named after the Roman gods Venus, so you'd think that the Romans would call Venus Venus, right?
I would assume so.
No.
Of course not.
No. Venus was not referred to, like Venus, the planet that you can see in the sky, was not referred to as Venus in English until the 13th century.
That's quite a long time after the ancient Romans.
Yes. So the Romans, it's really interesting because since it's such a bright, obvious thing in the sky that behaves differently to the stars around it, it has actually been known about, we think, since prehistoric times as a morning and evening star. So there's evidence that that was known about in some way as one single thing as well in ancient Sumeria.
Yeah.
Like a long time ago. There are some cultures that didn't distinguish it as a single thing and saw it as the morning and evening stars separately.
Oh, I see. Right now I understand what you mean. Yeah, they're identifying it as the one object.
Yes, so ancient Sumeria identified it as a single object,
wow.
But it's Venus or the morning and evening star have shown up in cultures like Babylonian, Canaanite, ancient Egyptian, and when it came to the Greeks, they actually saw the morning star as Hesperus, who is the son of the dawn goddess Eos. And they saw the evening star as Hesperus's twin brother, Phosphorus.
Oh, cool.
And there's phosphorus. There you go, it's glowing. And that's a little bit of word origin. And so, of course, the Romans had to tweak things a little bit to fit in with their whole vibe. So they had Vesper as the evening star and Lucifer as the morning star, which means light bringer, but was considered sacred to Venus.
Sure, I kept up with all of that.
Yeah. Basically, Venus is awesome, and because it is so bright in the sky, it has been known about for thousands of years. The Romans did not call it Venus, but they considered it sacred to the goddess Venus, but they called it Lucifer, which we may know as Satan, but Lucifer actually means in Latin light bringer, because if you go into your Christian stories, Lucifer is a fallen angel, was previously a light bringer, was previously an angel. So that's where all of that comes from. And then you get Roman Catholic Church, Holy Roman Empire.
Wow, that was a deep dive.
Venus.
Venus, it is. I mean, as it's unsurprising that such an obviously bright thing in the sky has captured human imagination since we were conscious and capable of communication.
Yeah, and I mean, I especially love I do love it being called Lucifer, the light bringer, because if you think about it, like, you could see it just in the dawn. Like, it would be a sign that the sun is about to rise. So
Yeah,
it is
it is
the
a
light
light bringer.
bringer.
Oh,
which
I like that.
I
That
just
is
think it's
very
quite
cool.
romantic.
It is,
Get
isn't
it? Venus, because of romantic.
Love it.
Hey.
Well done. Well, that was quite a deep dive. I want to go back to what you mentioned there, where you spoke about the soldiers at Troy.
Yes.
And because in the Iliad, when you read about it, there are two soldiers who stand out as well. Well, there are many soldiers who stand out, but there are two who are mentioned.
Are we talking Achilles and Patroclus?
No, I'm talking Castor and Pollux.
Oh.
Because this leads us nicely into constellation of the month.
Constellation of the month.
Orion.
It's Gemini.
It's Gemini.
Twins, more twins.
More
so many twins.
Yeah, so many twins. So Castor and Pollux are the names of the twins that appear in the constellation of Gemini. It's a very well-known constellation, sometimes even just called the twins. And yes, they appear in the Iliad as soldiers from the Greek soldiers besieging Troy, and they also, from an astronomical point of view, the two brightest stars in the constellation of Gemini are named Castor and Pollux.
Which is, it's very tidy.
It is, isn't it?
Which is quite often not the case in space stuff.
No. So from an observational point of view, if you want to see the constellation of Gemini this month, you need to look to the north. It's
quite low down on the horizon, right?
It is, yeah. So it's kind of underneath Jupiter at the moment.
Yeah.
And to the right, so sort of towards the northeast.
So a little bit like below. So like if I found Orion, I can maybe find Canis Minor, which is just a stick, but you know,
it's down there.
It's a dog, but it's a stick. But so you go Orion and Canis Minor, and you've got Taurus all sort of as their little trio, and then sort of below them.
Yes.
So like between Orion and the horizon, almost.
Yeah, almost to the right. In fact, here's an easier idea.
Oh.
This month, the planet Mars is located inside the constellation of Gemini.
That's amazing.
Yeah, just go out and find Mars. That's it's great how normally when you're trying to find a planet, the instruction is go and find these three stars and look for the planet next to it. No, to find Gemini, go and find Mars, and then next to it you'll find the two bright stars, Castor and Pollux, and they are quite distinctive, and it's quite interesting. So Mars is its bright red colour, and then next to Mars is the star Pollux, and that is also a red star.
Oh, awesome.
Not as red. They are still quite easy to tell apart.
Yeah.
But yeah, you'll see Pollux, it's a red giant star. In fact, it's the closest red giant star to Earth. It's only 340 trillion kilometres away.
Only?
Yeah. So 34 light years thereabouts. And then just next to that is Castor, which is, it looks like one star, but when you zoom in and then you zoom in a little bit more and then zoom in just a little bit more, it's actually revealed to be 6 stars, all orbiting each other in a complicated way.
Oh, wow. I was literally just about to ask, is it that thing where it's like, it's actually 6 stars that are, you know, still very, very far apart from each other. They're just so far away from us. But no, it's a...
They're a bound system. So it's a sextuple system, I guess.
Yeah.
So it's actually 3 pairs of stars, 3 binary systems.
Okay.
So take 2 stars and they're orbiting each other.
Yep.
And, you know, imagine that in your left hand.
Yep.
And then in your right hand, imagine 2 stars orbiting each other.
Uh-huh.
And now swing your left and right hands around each other. So you've got a pair of binary stars orbiting each other, like so. And then sort of with your left foot maybe.
Learn how to juggle and add another
binary
pair of stars.
that moves around this pair of binaries orbiting each other. So you've got...
Okay, so wait, all right, so there's 2 pairs, no, there's a pair of pairs orbiting each other.
Yes.
And then a third pair
that is orbiting that pair of pairs.
That is orbiting the pair of pairs. It's not like involved in that all 3 are orbiting cross.
No, it's...
Okay, so it is 2 and then a third pair.
Yep. But
okay.
But they are still so astronomically close together that from Earth it looks like one star.
Are they big stars then, or are they quite small?
There's a mixture. Yeah, some of them are sort of sun size, some of them are a bit smaller. I think one of them is a little bit larger as well.
Okay.
So yeah, you get a mixed bag when you open up the
But we're
Castor
definitely
bag.
not talking Pollux red giant size of any of the stars in that.
That's right.
Okay.
I'll have to go and double check exactly the size of all 6 of them. But yeah, there you go. So that's Castor and Pollux. That's how you see Gemini. That's really the only interesting observational site in the constellation of Gemini with the naked eye. There is another sort of bright star sort of towards the top, which is actually the feet of one of the twins, because they're upside down in our sky, as most constellations are in the southern hemisphere. But that's how you can see Gemini this month in the northeast at about 9 p.m. next to Mars.
Amazing. Thanks, Leon. I think that moves us around to another segment.
Burning questions.
So this is the segment where we ask you to send us questions at ParticleWA on Instagram. So just tag ParticleWA, write a space question of any kind, and send it, and we'll get it, and we'll try and answer it. And so we've had a question come in. Beth, what is our question?
So our question is from Morgan. Thank you, Morgan. Can we see other galaxies with the naked eye?
That is an excellent question, Morgan.
I've got an excellent answer.
I think I know what that answer is.
Yes.
Take it, Beth.
Yes.
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 Oh, good. All right. Well, next section.
Not really.
Let's elaborate. So yes, you absolutely can see other galaxies in the sky with the naked eye.
So we spoke a little bit about a couple of dwarf galaxies you can see in last month's episode, actually, because we were talking about Mensa, the mountain, which has clouds near it, and those clouds are the Magellanic Clouds. They're not really clouds; they're dwarf galaxies.
Yes,
but
that's right.
Can we see any, not dwarf galaxies? Big ones?
You look up and you see the Milky Way, and then you see the large and small Magellanic Clouds, and they're satellite galaxies. They orbit the Milky Way, a bit like how the Moon orbits the Earth. And you're saying, sure, that technically answers the question, but is there something a bit meatier and a bit more worthy?
I mean, I don't want to say a real galaxy, but you know what I mean?
Yeah.
A big one.
Yeah. And the answer is still yes.
Yeah! So, as far as I'm aware, the nearest galaxy to us here on Earth is, nearest big galaxy, not including the largest one, is Andromeda. So, Andromeda Galaxy, I would think, would be in the constellation of Andromeda.
That is correct.
But Andromeda's kind of hard to see from Perth.
Yes, that's right. So the answer is yes, you can see the Andromeda Galaxy from Earth. It's seeing it from Perth specifically is not impossible, but it is quite challenging because the Andromeda constellation only appears very low in the northern horizon for a few months of the year from Perth. If you are based in the northern hemisphere, then Andromeda is much, much higher up in the sky, and the Andromeda Galaxy is much easier to see from up north.
So, with the naked eye as well, you can see,
yes.
Can you tell with Andromeda that it's a galaxy? Does it look like the Milky Way and the Magellanic Clouds, where it's like a blurry cloud?
Yes, it's not quite as prominent, interestingly, as well for 2 reasons, as the Magellanic Clouds. So the Magellanic Clouds, they're not obnoxious, but you can't not notice them. Whereas Andromeda, if you're not paying enough attention, you can just skip straight past it. That's for 2 reasons. One, it's further away, but also it's an unusual galaxy in that its surface brightness is not as glowing as you might expect from a galaxy, which is so it's got lots of stars. You look at it through pictures of the Hubble telescope, but the way that translates into how it looks in our sky is it's just not as bright as you might think, but it is there. But when you look at it from Earth with the naked eye, you can kind of cover it up with your, kind of with the tip of your thumb.
Right.
But if you were to, crank up the brightness factor, it would actually be about 6 full moons long from side to side.
Wow.
So take 6 full moons, lay them across. Imagine that in the sky. That's about the size of your sort of palm.
Yeah.
And that's actually how big it is in our sky. But because it's quite faint and quite far away, it looks a lot smaller. It looks a lot harder to see.
I guess it's also because the individual stars that we see in our night sky are in our galaxy.
Yes.
So Andromeda would be behind those stars as well.
Yes.
So I guess it would be a little bit harder to
there's a couple of stars in the way. But it's more just the fact that it's far away and unusually faint.
Dim.
Yeah.
So are there other brighter galaxies that are further away? Like, Jupiter's really far away, but it's really big and bright, so we can see it really well. Like, are there any of those?
For naked eye galaxies, that's kind of it.
Okay.
Unless you've got exceptional superhuman sort of vision that can see beyond the darkest. But but you don't need a particularly powerful telescope to see even further galaxies.
What about like binoculars? Would they work?
Yeah, binoculars will definitely help you see more galaxies. Even just a small pair, but not like bird watching binoculars, but a somewhat good pair of binoculars. You can see many, many, many more stars, and yes, you can actually see more galaxies as well.
Cool. So I guess kind of in answer to the question, can we see other galaxies with the naked eye? We can see other galaxy with the naked eye and other dwarf galaxies.
Yeah, a pedant, or maybe someone who's not a pedant would just lump them all in the same category. So yes, great question.
Yeah.
And if you have any more burning questions, don't forget to tag us at ParticleWA on Instagram.
Amazing. I think that it is time for us to circle back all the way around to planets again with our spaceflight focus.
Spaceflight focus.
Spaceflight focus.
2, 1, we have a liftoff.
Yes, what I wanted to bring to people's attention this month is a really cool spacecraft that's on its way to Mercury.
Yay!
And
even though Mercury looks a little bit lame from here, hopefully it will look better from the spacecraft.
Yes, having just spent some time trashing Mercury earlier, it does come back to that particular thing, which is that Mercury is quite difficult to study from Earth because you can only ever see it for an hour or two before sunrise or after sunset, and because of that, there's a lot of glare in the atmosphere and there's a lot of turbulence in the atmosphere. It's kind of hard to point a very powerful telescope and get good science data. So what you do instead is not the next best thing, but realistically the only good option is to send a robotic spacecraft there.
Yeah.
But that comes with its own enormous swath of challenges.
So I had a little read about this and it confused me because it's sort of what we were talking about like a few months ago now with what did you call it? It's like astroflight maths and that kind of
yeah.
So the way that I was imagining
celestial mechanics, by the way.
That one, thank you. Astroflight maths, celestial mechanics,
same thing.
Yeah. So the way I was thinking about it was this: is like when we're trying to send a spacecraft to Mars, we're sort of like we can slingshot a little bit off our orbit. The problem is that when we're trying to send stuff to Mercury, it's a little bit like someone has pulled the plug in the sink, and the sun is the plug hole.
This plug hole, yeah.
So trying to send something to Mercury, which is it's not in the sink, is difficult because anything that you put in it's just going to go down the plug hole.
That's a good starting metaphor, I think.
Yeah. That's where I got to.
Yeah.
And then it was celestial mechanics.
Yeah,
and
basically.
I got lost.
Yeah, you get lost. Yeah, so what we're talking about, there's a spacecraft called Bepi Colombo.
Also, this is the one other thing I know about this. Bepi is short for Giuseppe. It's named after Giuseppe Colombo, who's the guy that worked out that you can do this
all this stuff.
Do the whole sink thing without it going down the sink.
Yes, that's right.
I just think it's cute. He's called Bepi. It's a nice nickname.
And
Sorry.
yes, no, that's good. The Bepi Colombo spacecraft has been flying to Mercury for a few years now, and it's a joint European Space Agency and Japanese mission. It's actually two spacecraft just bolted together, and when it gets there, it'll separate, which is actually pretty cool.
That's awesome.
But yeah, the problem which Beth is getting at is that if you want to go to Mercury, which is closer to the sun than the Earth, then it's kind of downhill the whole way.
Yeah.
The sun's gravity is going to pull you in, and so you will speed up, and so you'll get to Mercury, and you can wave at it as you go past because
because if you land on it, you're going to crash.
Yeah, you're going to smash into it, and so you approach Mercury with this enormous amount of speed, and so it's basically impossible to carry enough fuel to. You could turn on the rockets, burn the fuel, slow yourself down, but that amount of fuel would be, dozens and dozens of tons. It's hard to get that much fuel into space.
I was going to say, surely this is one of those, like, flood or famine situations where it's like either you have to take so much fuel with you that you can't do it, or you don't have to take any fuel at all because the sun's just going to pull you there anyway.
Yeah, basically. And so the question becomes, how do you lose that excess speed,
Right.
and this is and so this comes back into, we'll go back to the 1970s for a second, with the very first mission to Mercury was called Mariner 10, and it was a NASA mission, and NASA couldn't figure out how to slow down, so their spacecraft, the plan was to fly past Mercury once, and then
crash into the sun.
and then just get thrown out of the solar system.
Oh, okay.
But then along came Giuseppe Colombo, the Italian mathematician and scientist, and he figured out that if you fly past Venus at a very specific angle, Venus will actually fling you out the opposite direction. And these are called gravity slingshots. And
How are people this clever?
yeah, well, and that's the thing. There's no right or wrong way to choose a gravity slingshot. There's just better or worse. It's not like there's a optimal formula. You've just got to try it, see where it flings you, and then if that's good, can you then slingshot past another planet? Or
And this was in the 70s as well, so this is like before you could get a supercomputer to like
to do it for you.
do like hundreds of iterations of like super realistic modelling.
That's right. So yeah, that's 100% what they do these days. And but yeah, back in the 70s, this was first figured out by pen and paper by Mr. Colombo.
Oh my goodness,
And
thank you,
so-
Mr. Colombo.
Yeah,
Good on
and
you, mate.
by flying past Venus, Mariner 10 was able to get 3 flybys of Mercury for the same amount of fuel instead of just the one that NASA had planned for.
That's awesome.
But because of that, for the same reason, that's why it's so hard to get to Mercury and so difficult, because it takes a long time. You've got to fly past Mercury once, go around Venus, go past the Sun, maybe sometimes go past Earth or even Mars, and then you get back to Venus for a couple of days and you slingshot past again. So it means missions take forever. So there's actually only been one more mission since, which was a NASA spacecraft in sort of the early 2010s called Messenger, and it orbited Mercury for a few years. And now Bepi Colombo is only the third spacecraft ever to visit Mercury, and it still isn't quite there yet. As in, it's tomorrow, as of this recording, on the 8th of January.
8th of January.
It's doing its 6th and final flyby of Mercury, and again, it's going to approach it at just the right speed, at just the right angle, so that it will get slung out again, but this time not so far. So on previous flybys,
I really hope that we don't have to like come in and record an update tomorrow afternoon's podcast, being like, so it didn't work.
yeah, they were off by a couple of kilometres, and that was it. And so, yeah, the previous flybys of Mercury have slung it out in a different direction, and those have been calculated to go back to Venus to get slung back, and there's this back and forth game. But this last one it'll get flung out, but just enough. Close enough that it's the minuscule engines that the spacecraft has will be able to finally put it into orbit around Mercury, and that's the whole thing, to get into orbit around Mercury.
I'm going to describe this as cosmic pinball.
Yeah, pretty much. It's not a bad idea.
Yeah, just like in order for it to slow down enough, it's got to bounce around a load of other gravities and orbits in order to be in the right place at the right time.
Yeah, exactly. Yeah. And so a pop culture example of this is if you've seen The Martian, the film, or if you've read the book.
The documentary.
Yeah, the documentary. where
we sent Matt Damon to Mars.
Yeah, and when Matt Damon was on Mars, all of his crewmates, they were returning to Earth. But then they did they overrode NASA's rules, and then they slungshot past Earth to get back to Mars. That's that's an example of it.
Okay, but that's just once.
Once, yeah.
Whereas this is full pinball.
The trajectory of Bepi Colombo is enormously complicated. And the interesting thing about this, it's taken 7 years to do this, by the way, so it launched in 2018. That's when it gets into orbit around Mercury. That's when its mission starts.
Oh, okay. Okay, so we're not started yet.
Yeah, no, that's right.
We're just driving to work.
Yeah, that's right.
Okay.
And to be fair, it has taken some science data on the previous flybys.
Yeah.
But that's sort of like warm-up data. It's a taste of things to come. But yeah, once it gets to Mercury, it's going to split into two separate things, which, by the way, will be in about late this year, November 2025.
Because as far as I'm aware, there's the JAXA, the Japanese Space Agency machine, and the European Space Agency machine. And so it's going to split back up into those two?
Yes, that's right.
Okay.
Yes, and so the European orbiter is going to go real close to the surface of the planet, and it's going to map the surface in great detail. And it's got spectrometers. It's also got LiDAR to measure sort of the 3D height of the thing. And so, you'll get ultimately this sort of compositional map of the surface of Mercury, height value, but also mineral composition, like what's there and how strong is the gravitational field and things like that.
Awesome.
And then meanwhile, the Japanese spacecraft is going to be a little bit further out, and it's going to be studying the sort of the magnetic environment.
Okay.
Is the solar wind penetrating down? Is there plasma around Mercury? What minuscule material is being blasted off the surface of Mercury into space? That's what the Japanese mission will be studying.
Okay. So you said that this spacecraft has tiny engines.
Yes.
So I know that when we've got I know that sometimes when you've got stuff in a certain orbit, you kind of need to keep pushing it up and out into that orbit, otherwise it's just going to crash down. What's the end game for Bepi?
Good question. I think just to last as long as it can.
Okay.
It probably will eventually crash into Mercury. The sun's gravity interferes with things around Mercury.
Yeah.
That's why Mercury has no moons. If it ever had any moons, the sun would have eaten them a long time ago. So yeah, these spacecraft will need to do what's called station keeping, which is it's where you turn your engines on to stop yourself drifting away. Yeah.
Okay.
So yeah, it has what are called ion engines. So rather than chemical engines that burn fuel and throw exhaust out, throw lots of exhaust out, and that's their thrust, the ion engines burn. They don't burn so much as they ionize a gas, and they fling it out the back much, 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 much faster. But you can only use tiny amounts of it, so you only produce a tiny amount of thrust, but they're very efficient. So they just take a lot longer to work.
Okay, but you also don't need that much thrust in a vacuum.
No, that's right. That's you can accelerate constantly. And so the whole idea of this mission is to just really learn about Mercury. Mercury is a very unusual planet. It doesn't have barely any atmosphere at all. No atmosphere. It's very heavy or very dense.
Yeah.
And so where is that? What's that composition that's making it so dense? It's suspected to be iron and nickel and things like that. But it's also it's a rocky planet. There are 4 rocky planets: Mercury, Venus, Earth, and Mars. All of them very different to each other.
Yeah.
And so if we want to build this history of the solar system, we need to understand Mercury in more detail.
Yeah. Oh, that's awesome.
It'll be flying by Mercury tomorrow, losing enough speed to get into orbit, which will take it most of the rest of the year because of those minuscule engines. But then by November, it should have accomplished its orbit, and then the science mission can begin.
Well, hopefully we'll be able to check back in with Bepi in November. But before we move on, I have one last question for you. So it took 6 or 7 years to reach Mercury this time.
Yes.
But that's because it was pinballing. How long does it take to get to Mercury in a straight line?
In a straight line?
Or like a space straight line, like a direct flight.
A space straight line? Look, off the top of my head, not long, a couple of months.
Okay,
but,
all right.
Yeah, because as I said, though, you wouldn't be stopping at Mercury, you'd be zipping past it.
Yeah. Okay, cool. I just wanted a little bit of context for how much we needed to slow this spacecraft down. Yeah, it's a bit like, in fact, it's almost exactly. Getting to Mercury is quick, staying at Mercury is slow. Yeah.
And sort of the other, I'm taking off the saying, getting to space is easy, staying in space is hard.
Yeah.
And that's kind of what it is. It's all about managing your velocity.
All right. Well, hopefully, Bepi Colombo will not end up on our space fails and we'll have a successful mission.
I think so. Speaking of space fails of the month.
And $1 billion! It's 2 segments in one because something expensive has gone wrong. What's happened, Leon?
Yes. It's nothing bad, but it's one of those things where you look back and you go, yeah. The Artemis 2. So Artemis is the name of NASA's Return Humans to the Moon program.
Yeah.
And Artemis 1 happened in 2021, November. Not 2021, 2022. Jesus.
Time.
Yeah,
it's
time.
2025 now, Leon.
It is. And it was an uncrewed spacecraft. It was a test flight to send a spacecraft to the moon. It was a huge success. Everything went very, very good, except for as they re-entered, the little capsule that comes in and punches through the Earth's atmosphere. They had some problems with that.
That's the bit that's meant to keep the people from going on fire.
That's right. And it did. It actually worked, but it's got this protective coating on the front of it, or the heat shield, I should say.
Yeah.
And what happened was the heat shield burnt up more than expected. They were expecting some of it to burn up, but it burnt up more than expected, and they
that
didn't
means
know
it's
why.
not shielding what's behind it from heat anymore, I imagine.
Yeah, well, the as I said, it actually worked. Like the temperature data inside the capsule, the Orion capsule, as it's called, was fine.
Okay.
So if people were on board, it was fine, except for the fact that they didn't understand why did the heat shield do that.
Yeah, and that
so
is...
and when you're NASA about to put people on this $1 billion rocket, you
Yep.
want to know exactly why everything is happening.
Yep.
And what they eventually found is that as it asymmetrically sort of melted away, these tiny little bubbles would form in the surface where air could pull and attack this. So instead of like wearing away smoothly, it sort of wore away unevenly,
Right,
and got this sort of pockmarked effect.
And you've got that like perpetuating areas of heat get hotter and then heat.
And if you go on much longer, then you'll run into trouble.
Okay, so we have worked out why it failed.
Yeah,
now.
and it's interesting because the way this particular crew re-enters is that it, rather than punching straight down through the atmosphere, it sort of comes in at a sideways angle and skims and then bounces off. And then when you skitter a rock across the surface of a lake and it goes bounce, 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 splush. That's actually what this.
Just try to imagine being an astronaut in that situation, having to bounce off.
That's exactly
Earth.
how it does
my
it.
goodness.
Yeah, so it bounces. So yeah, it comes in, skitters off the atmosphere, loses some heat, skitters off it again, and then eventually comes back down. And so it took NASA so long to understand this that the Artemis 2 mission, which was going to be a crewed flight to the moon, they weren't going to land on the moon, but they were going to repeat the first mission, go to the moon, go around it for a few days, and then come back home, skitter across the atmosphere, and punch back down. That was supposed to launch in like November last year. November 2024 was it sort of. That was already its delayed date, and unsurprisingly, it's January 2025. Hasn't launched yet.
But you know what? I'm really glad that we're not setting a precedent for putting astronauts in space when we don't know what went wrong the first time.
No, that's...
Again, it's a fair few of our space fails where it's like, this unmanned thing went wrong. I'm so happy that the unmanned thing went wrong and that we have not gone, oh well, and put people in a rocket.
Go for it anyway.
Yeah.
So November 2024, then it got pushed back to September 2025, and now it's been pushed back to April 2026.
Right.
So, and that's for Artemis 2. So the second test flight, which again is still not actually going to land on the moon. It's just going to fly to the moon to check that the humans and the integrated systems are all going to be okay.
So which part of this is our $1 billion?
So the $1 billion is how much do you think $1 billion will get you in an Artemis mission? So to send people to the moon, how much do you think $1 billion will get you?
I think it will get you most of a rocket ship, but not the fuel or the people on it.
That's actually not a bad estimate. Yeah.
Yes!
So it's kind of hard to really put a cost on the Artemis program at the moment because they've only done one, but they've had to do a lot of R&D, and R&D is always expensive.
Yeah,
but
and also like if you've got this that's been delayed from September.
Yeah,
like
you've got people
November
you need to pay for longer and all of this.
Yeah, like you've got 2 more years worth of work to add on, so obviously that's going to be expensive.
Yes. But it's estimated that each Artemis mission, as a standalone, will cost about $2 billion, which is a lot of money.
That's a lot of money.
And people will hark back to the Apollo program back in the day and say, well, they did it for, $10 million a launch or whatever. I don't know the number. But that was 1960s dollars. And when you scale it up for inflation, it works out to be about slightly more expensive these days, but not actually. It's not like they were doing it on the cheap back then either.
Well, no, and also they used 25 megabytes of data or something. Like, it's not that, but like some ridiculously small amount of computing power to do that.
It was pretty old technology.
Yeah.
But it is interesting that the slow cadence of it is what pushes the price out.
Yeah.
Because yes, if you put in, say, $10 billion of R&D, but we're then able to launch a rocket every 3 weeks.
Yeah.
For a fraction of the cost, then that price per launch over the lifetime of the project will come down.
Yeah.
But because they've only had one launch so far, and they keep pushing out their second launch, and they might only be able to launch once every 1 to 2 years, the cost per launch is very, very high.
So at the moment, $1 billion will get you half of an Artemis mission.
Half of an Artemis mission.
Awesome. I think that brings us to, I keep saying awesome today, and I don't know why. It's my crutch word today.
It's a good day.
It's not a bad crutch word.
No.
That brings us to our final segment. a fan favourite, if the fans are me and Leon. It is Space Picture of the Month.
Space Picture of the Month.
Oh, ooh. Leon has sent me a map. Well, he sent me... It's got a title, which is helpful. So, what I'm looking at is, apparently, the difference from average sea surface temperature observation 16th December to 22nd December 2024. So, I'm looking at a map of the world, which to me, as a Brit, is very interestingly centred around the Pacific Ocean. So it's a slightly unusual map. Africa has been cut in half, and London has been separated from the rest of the United Kingdom.
It's in a rectangular projection.
Rectangular projection, yes, absolutely. So we've got a whole world on here from 80 degrees north to 80 degrees south, and a coloured temperature graph going from difference from average degrees C, -4 being a little bit of a darker blue, to +4 being a red. And what I'm seeing, the baseline, it says in the bottom corner. I love pictures which are charts, which have so much information on them. So the baseline that they took to get what the average temperature they're comparing to is from 1991 to 2020. And it looks like the Australian Bureau of Meteorology are the ones who have compiled this map. And it was created on the 23rd of December. So they used their data from the day before. So this is the weekly average, so just 16th of December to 22nd December last year. Japan is quite warm. There's some really warm bits near Japan, and the northern Pacific Ocean is looking generally warm. It is interesting, like, it does seem like the swathes of temperature are generally pretty consistent. So you've got like hotter than normal patches and colder than normal patches. So there's a big spike of cooler than usual sort of coming off the west coast of South America, which is interesting because it comes sort of from Chile and then goes up to the equator in a remarkably straight line. Like, when it comes to Earth science data, it's very often not that straight. Then Australia, as you may expect, it has a lot of warmer than average sea surface around it as well, with a big, well, not a big, but a little spike near Exmouth, I think, and then a couple more hotspots off the east coast of New Zealand. I mean, I say off the east coast, I mean pretty deep into the Pacific Ocean. Then you've got the one bit where there seems to be a fair amount of mixing around of these colours is to the south of Africa, where like there's hotter than average patches and colder than average patches. It's almost stripy.
Yeah, lots of turbulence going on there.
Yeah, I think that's what I'm seeing.
Yeah, that's what we've got. And yeah, so the bit that I think is worth drawing people's attention to is, there are parts of the ocean that are warmer than average and parts of the ocean that are cooler than average, as identified by red and blue colours in this image.
There is also quite a lot, which is just average.
Yep.
Which is quite nice to see.
But the bit that's really, the bit that I want to draw your attention to, really, is the bit that this unusually straight line in the middle of the Pacific.
Yeah.
So if you're looking at this map, there is an unusually cold band of water starting from essentially South America that stretches all the way across the equator, basically to Indonesia. And so there's this big blue smudge all over the Pacific Ocean here. And then up in the north and the southern Pacific Ocean, it's a bit redder where it's warmer. And this is what is causing a little bit of curiosity and interest around, well, no, not a little bit, a lot of interesting speculation amongst weather forecasters at the moment, because this is what appears to be the build-up of a La Nina event.
Oh. Now, La Nina, if I recall correctly, is the cousin of El Nino.
El Nino, that's right.
That means storms are coming, Leon.
Yeah, storms are coming. So, and this is it's part of a much larger natural climate cycle called the El Nino Southern Oscillation. So let me paint a picture for you.
Okay, I'm ready.
So if you have the well, let me try again. Let me ask you a question. What can you tell me about the top of the ocean, the temperature in the top few meters of water compared to the temperature 100 meters down?
100 meters down is way colder.
Yeah, that's right.
You've not got the sunlight warming it up.
Yeah.
It gets real cold. And sometimes you can get this in the ocean as well, and it happens to me where you're nice and floating on top and you're nice and warm, and then you put your feet down and it's cold and you've got to bring your feet back up to the warm bit.
Yeah, exactly.
Like, it's not even meter. It's like it's just a people
a couple
size.
of meters, yeah.
Yeah, don't put your feet down there. It's cold.
But yeah, so the whole point is that the surface of the ocean is warmer than get further down.
Yeah.
Now, in the Pacific Ocean, here's like under normal circumstances. So this is not normal circumstances.
This is not normal. No.
Under normal circumstances, what happens is you get the wind tends to blow from east to west, so from the Americas to Asia, and that it's a gentle-ish kind of breeze, well, gentle-ish, but you get this sort of this general movement of warm water being blown from east to west across the Pacific. That's like on average.
So the normal current is a gentle east to west.
Yes, the normal surface current at the equator, yes. However, sometimes, for reasons that aren't quite completely understood, those winds can be stronger.
Right.
And so they blow a lot stronger, and so they blow more of that warm water towards Australia, towards Indonesia, towards Asia. And if you look off the east coast of Australia, what colour is the surface of the ocean there?
Red.
Colour? Red, but yeah, rather.
No, not the surface of the ocean.
The interpretation is
on
warm
this
water.
graph. On this graph, the ocean is red.
Yes.
In front of Australia, which suggests warm water.
Warm water. And so when these winds are unusually strong, it pushes the warm water towards Australia, Asia, Indonesia, and it exposes the cool water underneath. And that's what we call a La Nina, these stronger than usual winds. And it's a bit of a chicken and egg situation. Does the water cool down and it drives the winds, or does the winds pick up? And what that means, though, is all of that warm water is now over near the east coast of Australia. Warm water evaporates more readily, forms storms more readily, and so when La Nina events happen, we tend to get flooding and big storms in eastern Australia.
Right.
And that's what's unusual, is that there seems to be this build-up of an El Nino thing during summer, which usually they happen sort of August, September, springtime.
Yeah.
And they last a few months, but yeah, it's possible. It's still not 100% confirmed. Like, the Bureau is very conservative with these predictions.
Yeah.
But it's possible that we may be in for some pretty severe weather in the eastern part of Australia because of this La Nina event over the next few months.
Oh. That's really interesting. So all of this data will have been gathered by satellites?
Yes, that's right. Satellite data that measures the sea surface temperature. That's a common thing that they do.
Awesome.
And just to complete the story, the El Nino is the other way around. When the winds just stop, and so all of that water that's been blown towards Indonesia and Australia sloshes back to the other side of the ocean.
Right.
And you get floods in South America and weird weather all in the Americas, that sort of stuff.
Okay.
So that's the El Nino. But yeah, this seems to be, we're on track for a La Nina, and we've had 4 in the last 5 years. Ooh. Usually they're on average every 2 to 3 years, but 4 in the last 5 years is very unusual, and especially one during summer.
Okay.
So keep your eyes on the weather.
Yeah, absolutely.
Especially if you're in the eastern states. Beth, what's it going to be?
Something a little bit silly. I really hope that this is the correct JPEG. Yeah!
Okay.
What you got there, Leon?
I don't even know how to start to describe this. Firstly, it's mostly dark, and the only two things, it's mostly black, I should say. The only two things of colour are 2 red, almost triangular shapes. They've got one straight edge and 2 curved edges, and one curve is convex and the other one is concave. I think the best way to describe this is to describe how I think this picture has been produced.
Okay.
Is I want you to imagine you're standing next to one of the pyramids of Egypt, or any sort of pyramid, and behind the pyramid is the sun, so there's a big triangular shaped wedge taken out of the sun, but then missing from the top of the sun is a circular cutout, almost like the moon might be about to pass in front of the sun. So if I were to take a guess, I would say this might be a photograph of an eclipse taken from behind a pyramid.
He's so good. He's just gotten the wrong monument. This,
close.
This is the top of the Washington Monument in silhouette during a partial solar eclipse on April the 8th.
Oh, that was the eclipse last year.
The eclipse last year, yeah. So I found something which really overwhelmed me, which was NASA has released their top 100 space photos of 2024.
Wow.
So I got a little bit lost scrolling on that. And yeah, I found this one, which was,
That's
a
really cool.
partial solar eclipse with so it is a pyramid, but it's actually just a very small pyramid on the top of a big stick.
And that's interesting because, the top of the Washington Monument is tapered and it points.
Yeah.
But the fact that you can see in the size of this photo, that little tapering point covers most of the sun.
Yeah.
So you can tell that the way they took this was the photographer was probably standing a kilometre away with a very, very powerful lens, had planned this shot weeks in advance.
Well, the incredible thing, I love nerds. I am one. I love nerds. Because the NASA photo account has that, it has exactly what camera was used to take this.
Oh, perfect.
This was apparently, I'm going to read out a bunch of things I don't understand. A Nikon Z9. It says VR 200 to 500 millimeters, f/5.6e. Then you click on show settings, and it also says there's a little exposure time, 1/1000. The ISO was 4000. Flash brackets off, did not fire. And it's got where tagged as well with the Burns Discovery Historical Washington, D.C., United States.
Perfect.
So that's exactly how it was taken. There you go.
I know enough about camera settings to know that those numbers weren't meaningless, but I don't know enough about camera settings to know what the numbers meant.
What it meant was a really cool picture.
Yes, that's right. And if you're failing to imagine all that, it looks like a pair of spider eyes.
I saw this and I thought, that looks like a reverse pumpkin.
Yeah.
It looks like a reverse Halloween pumpkin.
A reverse Halloween pumpkin. Yeah, that's actually not a bad description.
Well, yeah. Or like a pumpkin when the inside is lit.
Yeah.
And you can just see the darkness.
Yeah,
it's
just
a
see
pair
like
of
two eyes cut in a pair. Yeah, into a pumpkin.
Or maybe orange ladybird wings.
Ooh, yeah, that's
just
a good
against
one.
a black background.
Yeah, just imagine ladybird wings and delete the rest of the ladybird.
Yeah.
You've cut out the wings on Photoshop.
Yeah.
That's what you've
just
got.
the little carapace.
Yep.
But yeah, I just thought that this was a pretty awesome photo, and I wanted to bring a little bit of attention to the fact that NASA have published their
100 best photos.
Their
of
100 best 2024 photos, and there's a whole range of stuff on there. There's stuff from astronauts preparing for launches, like people watching the solar eclipse. There is a not a long exposure, but like a compound photograph of a rocket launch, so you can see the path of the.
Oh, cool! I love those ones.
Yeah. There's some artsy black and white shots of people, SpaceX Crew 7.
Long story short, I think I know what we're doing after this.
Yeah. There's also a picture of a dinosaur wearing eclipse glasses.
Of course there is.
On the Children's Museum of Indianapolis. So, yeah.
Why not?
Go check it out. It's great.
Well, I think that's all we've got time for, Beth.
Yeah, I think it's probably more than we had time for, really.
Yeah, I'd say so. So thanks for listening, everybody. As we said, get us your questions to Particle WA on Instagram. We like hearing from you.
Yeah, absolutely.
And if we might be able to try and answer them. Otherwise, thanks for listening, and we'll see you next month when we talk about the night sky and all of the space news in the month of February. Thanks for being here, Beth.
Thank you for having me, Leon.
And thanks for listening. We'll see you next time. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information. At Instagram.
And on Instagram?
On Instagram.
How do the youths communicate nowadays, Leon?
I don't know.